Okay, so I want to spend a little bit more time on the details of MapReduce versus relational databases beyond just the sort of how the query processing happens. We saw that parallel query processing is largely the same. Many of the algorithms are sort of shared between them. There's a ton of details here that I'm not going to have time to go over. But the takeaway is that the basic strategy for performing parallel processing is the same between them. But there's other features that relational databases have, and I've listed some of them here. So we've mentioned declarative query languages, and we've mentioned that those start to show up in Pig and especially Hive. Now there's a notion of a schema in a relational database that we didn't talk too much about, but this is a structure on your data that is enforced at the time of data being presented to the system. So any data that does not conform to the schema can be rejected automatically by the database. This is a pretty good idea because it helps keep your data clean. It's not real feasible in many contexts because the data is fundamentally dirty, and so saying that you have to clean it up before you're allowed to process it just isn't going to fly, right? And so this is one of the reasons why MapReduce is attractive, is it doesn't require that you enforce a schema before you're allowed to work with the data. However, it doesn't mean that schemas are a bad idea when they're available. And in fact, really, even with MapReduce, a schema is really there. It's just that it's hidden inside the application, right? So when you read a record, you're assuming that the first element in the record is going to be an integer, and the second record is going to be a date, and the third record is going to be a string. So that schema is really present. It's just present in your code as opposed to pushed down into the system itself. And there's a lot of great empirical evidence over the years that suggests it's better to push it down into the data itself when and where possible. And in fact, you're starting to see this. So Hive and Pig, again, have some notion of schema, as does DriveLink, as does some emerging systems. There's a system called Hadapt that I won't talk about really at all, but combines sort of Hadoop level query processing for parallelism, and then on the individual nodes, there's a relational database operating. And one of the reasons, among many, is to have access to schema constraints. Fine. Logical data independence. This actually you don't see quite so much. So this is the notion of views, right? Does the system support views or not? And you haven't seen quite as many instances of Hadoop-like systems that support views, but I predict they'll be coming. Indexing is another one. So we talked about how to make things scalable, that one way to do it is to derive these indexes to support sort of logarithmic time access to data. That's not available in vanilla MapReduce. Every time you write a MapReduce job, you're going to touch every single record on the input. You're not going to be able to zoom right in to a particular record of interest. That's wasteful, and it was recognized to be wasteful. And so one of the solutions, you see people adding indexing features to Hadoop, and HBase is an open source implementation of another proposal by Google for a system called Bigtable that, among other things, provides kind of quick access to individual records. And HBase is designed to be sort of compatible with Hadoop, and so now you can design your system to get the best of both worlds. Okay, so you can get some indexing along with your MapReduce style programming interface. And once again, I'll mention Hadapt here as well. One of the motivations for Hadapt is to be able to provide indexing on the individual nodes. Okay. Fine, so I'll skip caching materialized views. So this is the same thing as logical data dependence, except you can actually pre-generate the views as opposed to evaluate them all at runtime, but we're not going to too much about that. And then transactions, which I'll talk about in a couple of segments in the context of NoSQL. But while databases are very good at transactions, they were thrown out the window among other things in this kind of context of MapReduce and NoSQL, and they're starting to come back. Okay. But remember, what MapReduce did provide was very, very high scalability. So this is thousands and ups, 1,000 of machines and up. And it also provided this notion of fault tolerance. So relational databases didn't really treat fault tolerance this way. They were unbelievably good at recovery, right? If you were, because of this notion of transactions, if you were sort of operating on the database and everything went kaput, given some time, it would figure everything out and recover, and you can be guaranteed to have lost no data. Okay. That's fine, but that's not the same thing as saying during query processing, while a single query is running, what if something goes wrong? Do I always have to start back over from the beginning or not? And sort of the implicit assumption with relational databases was that your queries aren't taking long enough for that to really matter. But in the era of big data, of massive data analytics, of course you have queries that are running for many, many hours, right? And so having to restart those, and of course they're running on many, many machines where failures are bound to happen. And so that context is something that MapReduce sort of really motivated. And now you see modern parallel databases capturing some notion of fault tolerance in general. Okay. So this is sort of a list of some partial list of contributions from relational databases, and this is a partial list of contributions. Well, maybe a complete list of contributions from MapReduce. And my point is that you see a lot of mixing and matching going on. The design space is being more fully explored. It used to be sort of all about relational databases with their choice in the design space, and then MapReduce kind of rebooted that a little bit, and now you see kind of a more fluid mix. People sort of cherry picking features. Okay, fine. And then the last one I guess I didn't talk about here is what I think was really, really powerful about MapReduce is it turned the army of Java programmers that are out there into distributed systems programmers, right? A mere mortal Java programmer could all of a sudden be productive processing hundreds of terabytes without necessarily having to learn anything about distributed systems. That was really, really powerful, right? The analog in databases was, I mean, you had to become a database expert to be able to use these things. Okay. And so I think that impact is hard to overstate, right? The ability for one person to get work done that used to require a massive team and 6 months of work was significant. All right.